Okay, welcome back. In this video, I'm going to go over some of the concepts and the practice problems in U1A8, which is all about fractions, ratios, rates, and percents. This is the longest, and for many, it might be the most difficult of our activities in this unit. This is our last activity before the test, so please take your time. You might want to spend maybe 2 days working through this and then working on the assignment as well. In this video, I'm going to go over some practice problems and talk about some of the concepts. So the first one is we need to write each decimal or fraction as a percent. And the way we do that, well, first of all, what does the word percent mean? I love etymology, or thinking about where words come from, breaking them down into roots. So percent is per and cent. What does per mean? Per means for every. If you think about kilometers per hour, that means kilometers for every hour. So per means for each or for every. And then cent, think about words that have cent in them, have cent as the root. They always have to do with hundred. If you think about a cent in money, there's 100 cents in a dollar. There are a lot of things in London named Centennial. Centennial means 100. So any building or park named Centennial is named after Canada's 100th birthday, which was 1967. You've probably heard century, which means 100 years. Centurions in Rome, I think, were soldiers that fought in groups of 100. I'm not 100% sure on that one, but you might want to look it up. If you have any other words that use that root cent, if you can think of them, you could post in the comments of this video. That'd be awesome. But what we're going to do is we're going to change all of these decimals and fractions into percent, which means writing them out of 100. So if I have a decimal, all I need to do is multiply by 100 or move the decimal place 2 spots to the right. So 0.6 is the same as 60%. 0.12 is the same as 12%. When it's a fraction, what you're really trying to do is think about how 2 out of 5 is the same as what out of 100. Well, on the bottom, to get from 5 to 100, I've got to do times 20. On the top, if I did times 20, I would get 40. So it must be 2 out of 5 must be 40%. Another way to think about that is just if you know 2 divided by 5, that's 0.4 as a decimal. And then you can just do 0.4 times 100, which equals 40%. So that's another way to kind of get to the same place when I'm changing a fraction to a percentage. Same thing, if I'm doing 10.5 out of 15, well, to turn a fraction into a decimal, I can just divide numerator by denominator. So I get 0.7 and then multiply by 100 to get my answer of 70%. So if you got 10.5 out of 15 on a quiz, of course, that would be a grade of 70%. Percents can be bigger than 100. It doesn't always make sense in context of marks at school, but 1.5 is equal to 150%. You could think about something growing. The growth rate could be 150% if the population was, more than doubling. So we can have percentages that are bigger than 100 if you have bonus marks on a test or things like that. So percentages can exceed 100. Same thing here, turn the fraction into a decimal. So 9 divided by 3 is 3, and then times 100, so that would be 300%. Same thing when we're going the other way. We're going to turn a percent into a decimal. We're just moving backwards. So a decimal is really something out of 1. So I'm going to divide by 100, which is really just moving the decimal place 2 spots to the left. Each time I'm moving the decimal place, I'm dividing or multiplying by 10 because we're working in a base 10 system. So again, I'm moving that decimal 2 places. So 110% is 1.1. You might have heard that expression in sports. I'm giving 110%. It's not really possible, but in math, it works out fine. 43.2%, well, it's a little bit more than 43%, so it's 0.432. Just be careful of where you put in the decimals. If it's a single digit percent, we're going to need to add in that leading zero, so it's 0.028. And again, if you're ever not sure, again, remember that we're just dividing by 100. So 0.1% is something that's very small, 0.001. So again, I'm moving that decimal spot 1 spot and 2 spots to the left. Again, if it's bigger than 100%, the decimal is going to be bigger than 1 whole. So 325% would be 3.25. If the percentage is bigger than 100, the decimal is bigger than 1. Expressing as a fraction in lowest terms, the way we always want to start that is a percentage always means over 100. So 15% is 15 over 100. And then I need to find the greatest common factor. to reduce. So 15 and 100, I can divide them both by 5. So I have 3 over 20. 50%, some of them you might know. 50% means you're getting half of the questions right, so it's 1/2. Another way of thinking of that is that my greatest common factor of 50 and 100 is 50. So I'm dividing top and bottom by that. 46, they're both even. When the numbers are ever even, I can always divide by 2, and then 23 is prime, so I can't make it any smaller. Again, the math doesn't change when the percentage is bigger than 100. I can divide both of these by 25, and I'll get 7 over 4. If you want to do this in multiple steps, that's fine as well. So let me show this question maybe again at the bottom of the page. So if I have 175 over 100, I could first divide by 5, divide by 5, and I have 35 over 20. But then I'm still not done. They both end in 5 or 0, so I know they're divisible by 5. So then I have 7 over 4. So you can take multiple steps if you want, just dividing by common factors each time. If you find the GCF and divide by that, then you can do the problems in one step. And it's always nice to have fractions in lowest terms. But if it's 39 over 100, remember, I can only divide 100 by 1, 2, 4, 5, 10, 25, and 50. But 39, the only factors other than 1 in itself are 3 and 13. So I can't actually reduce this. It's already in lowest terms. 5 over 100, I can divide both by 5 is 1 over 20. So it's a good habit to get into leaving fractions in lowest terms. It makes it easier to communicate your ideas. And percentages are always whatever number it is out of 100. So remember that percentage symbol. We love short forms and symbols in math, but all that really means is out of 100. So 5% is 5 out of 100. When we're determining the value for each statement, there are a couple ways to think about this. For example, 10% of 80, 10% is just 1/10 of 100, so 1/10 of 80 would be 8. 20% of 70, well, we know 10% of 70 is a tenth, which is 7. 20% is twice that, so it would be 14. So when we have nice round numbers like 10%, 20%, 15%, we can use kind of our knowledge of fractions and ratios. So again, 15% of 50, well, 10% of 50 is 5, 1/10. And then 5% is half of that, which is 2.5. So if I add those together, 15% is 10% plus 5%. So it's 5 plus 2.5 is 7.5. So that's how I would do that, kind of working in my head. If you're more comfortable in the calculator, what we could do is turn that percentage into a decimal by dividing by 100. And then of in math always means multiply. So if I multiply 0.15 by 50, I'm going to get that same answer of 7.5. So if you don't like the numbers or they're not round or you think you're going to get a decimal, I can always convert the percentage to a decimal by dividing by 100 and then just multiplying. So here, for example, 0.65 times 12 equals 7.8. So what that's really saying is there was a quiz out of 12 marks and you got 65%, then you must have scored 7.8. And again, just be careful when the percentages are small, you still have to divide by 100. So 0.2% as a decimal is 0.002, and then I multiply that by 3,000, and I get 6. So it's less than 1%. It's actually 1/5 of 1%. I'll let you work on the other ones, or you can always, of course, check the answers by clicking this button. Doesn't work on paper, but it should work on the computer screen. And in the last one, we're kind of working backwards. We're almost doing a little bit of algebra. 25% of a number is 5. That's another way of saying 5 is a quarter of what number? Well, 4 5s is 20, so 5 must be a quarter of 20. And you can kind of check your work. I could do 0.25 times 20, which sure enough is equal to 5. So we're kind of working a little bit backwards. 8% of what number is 10? So you're kind of looking for the total. So you're kind of thinking 0.08 times what equals 10? Again, I'll let you kind of work through those on your own to figure out the answer. A little bit, you could use a little bit of algebra. You kind of work backward, think about set up your ratios. Another way of saying that is 8% of something. So 8 out of 100 is the same as 10 out of what? So you could put an X in for what, and we could use some cross multiplying, which I'm going to go over in a second. So those are some hints, different strategies to solve question 5. The last thing you covered in this unit, which might be the hardest thing we've learned so far, is solving by cross multiplication. So you may have done this in grade 8. Let's look at example here. So we're trying to figure out what is x to make these ratios, these fractions equivalent. Well, you know that to keep fractions equivalent, I'm always doing the same to the top and the bottom. So to make 12 into 36, I'm multiplying by 3. So what times 3 equals 9? Well, x has to equals 3, because 3 times 3 is 9. Same thing if I'm going the other way, if it's becoming smaller. To make these fractions equivalent, well, on the denominator, I've divided by 5. So what number divided by 5 is 8? Well, it must be 40. 40 divided 5 is 8. So that's one way to work through these questions. So x would be equal to 40. Another way is to use the cross-multiplying technique, which I'll show you now. And what's nice about this is this works no matter where x is, on the top or the bottom, on the right or the left. And I'll show you why this can be useful, especially when we start working with decimals. This might be a little bit more difficult because 8 doesn't go into 20 evenly, so it's a little bit harder to use the same method. But what we do know is I want to have x by itself. And on this side right now, I'm dividing by 8. So on the other side, if I want to get rid of this 8, I'm going to multiply onto the other side. So I'm going to do x equals 9 multiplied by 8 divided by 20. Because we're working with decimals, I might as well use my calculator. 9 times 8 is 72 divided by 20. So x has to equal 3.6. So when we're cross-multiplying, we're always going to multiply first the diagonal that doesn't include the variable x, and then divide by the remaining number, the number that was kitty corner or diagonal from x. So here it's going to be 9 times 8 divided by 20. And what's nice is that that works no matter what the numbers are and no matter where our variable is. So let's use, let's use p instead of x. So if I want to figure out what p is in one step, I can multiply the two numbers on the diagonal that don't include p. So I can multiply 17 by 11, and then I can divide by the leftover number that's kitty corner. So p must equal 17 times 11 divided by 35. Then maybe I'll round to 2 decimal places. So I'm really doing 2 steps of algebra at once when I cross multiply. I'm getting rid of the 17 on the bottom here by multiplying it by 11. Then I'm moving the p over, and then I have to divide by 35. So I'm kind of skipping a step of algebra when I cross multiply. So take your time practicing these questions. You could start by using the method that you may have learned in elementary school of equivalent fractions. And you can move on to trying this cross-multiplying, which can skip us some steps of algebra. And again, let me know if you have any questions by commenting on the video or sending me an email. And then do take your time as you work through all of the content in this activity, because this is a little bit longer and perhaps a little bit newer or more challenging than what we've done so far.